Hey, Aleks here with Harper, talking today with Jeff Darnton. We're doing this web performance series, and we've been doing a few things. We've talked about early hints, we've talked about redirects, we've talked about pre-rendering, pretty much all those things that you really want to do if you want to have the highest performance. Today, we're going to jump into the next category. We're talking about long tail cache. So, without further ado, Jeff, what is a long tail cache?
Yeah, long tail caching is more of a strategy. Like caching is what we do and what others do, and it's a way to store whatever the resource is that you're requesting in a different place than where that resource comes from. So if it may be a data center or a database call at your origin, you use a cache to store that maybe at a Harper layer or a CDN layer or on a user's device. Long tail caching, specifically, we're talking about very large catalogs of content, whatever that content may be. And it's the part at the very, very end that isn't accessed very frequently. And so that's a challenge for traditional caching systems to cache, but still may be important. And so there's some specific strategies we can do to get that long tail, those least frequently hit objects into a cache that are still able to be served and perform.
Okay, so when you talk about traditional caching system, I'm assuming you're talking about CDNs here.
Yeah, right. That's where everybody starts with caching, and in any sort of modern web application that's running at scale, you want to use a CDN. You should use a CDN, but the vast majority of CDNs are request driven. So a request comes in, it hits the CDN. If it has the object in cache, it'll serve it. If it doesn't, it'll go retrieve it from your origin and it'll pull it into its cache and store it there for some period of time, according to a time to live (TTL) rule. But those are usually shared caches. So there's some sort of rule for moving things out of the cache, either least recently used or first in, first out, variety of different strategies that CDNs employ. But what it means is that TTL, that time to live of that object, may not be at how long that object actually stays in cache at that CDN. It might get moved out faster, or even if you had a relatively long time to live, 1 day, 2 days, your object might only be accessed once a month. And so it's not going to be in that cache the next time the person comes there. So CDNs are great and you should use them, but they're really designed to protect you for those very frequently accessed pieces of content and aren't necessarily great at that.
Okay, so it sounds like CDNs can't hold it all. What is the impact on that on business when somebody comes to that page, it's not in the cache? Like, what happens? How much is that costing the company?
The kind of old adage is the fastest byte is the byte that was never sent. So in a perfect world, right, we would have every single thing that the user needs on their device. And therefore it would never leave, because as soon as we leave, we're going over the network, and going over the network takes time. We can only go as fast as the speed of light on that network. And so wherever that piece of content is, we've got to travel further than that to travel farther than we want to go get that piece of content. So yes, the performance is there, and that can drive, again, whatever the transaction is that you're trying to drive action on. I used to work with one. It was an airline company, and they had service manuals. Every time you're sitting in the back of the plane, and they say, "Oh, we got to have maintenance come on," and they go up in the cockpit, and they're doing something, looking at a light. Right? They always walk in with an iPad. On the iPad is like a 3 GB PDF file, right? And they got to have one of those for every plane. And so if you're at some remote airfield somewhere and you haven't downloaded that 3 GB PDF and you've got to go get it somewhere, that content might not be accessed that often, but now you've got a plane that's waiting for somebody to download a piece of content. That's a scenario where a cached object close to the end user is super, super important. And it's matter at that point in time. And even though it's a PDF, it's still a valuable piece of content. So the things that you cache don't always necessarily make sense. Oh, it should be an image. Oh, it should be this. Like sometimes it's a dang PDF file that somebody needs once every 6 months, but it's important to get it out there fast.
Wow, that's interesting to having worked with the airlines like that. Yeah, I never thought that about those
Right?
PDFs
Yeah, you're
before.
always, well, what are they looking at? Well, yeah, they're just opening up a PDF file, trying to find whatever the page is for that light, to be able to make it go away. So yes, the performance is there, and that can drive, again, whatever the transaction is that you're trying to drive action on. But the cost piece is there as well. So we want to not only make it performant, but we want to save that cost. Every time we've got to go back to that origin, if that origin is in a cloud provider, let's say, Amazon or Google or Azure, whatever cloud you may be using, you're paying not only for the dollars or for the bytes to go in, but you're really paying for that egress cost as well for the bytes to come out. And so we have now performance cost of having to go and retrieve something. And we also have the business cost of how actual dollars to serve that. And we have to be scaled much higher at the origin to be able to serve whatever the volume is of traffic that's coming in. And so we kind of talked about before, like pre-render for bots, but this is also for humans. We still have this same long tail problem there. So cost and performance are both important for a business perspective from an offload standpoint. And again, you kind of need to set some targets about what you want that offload to be. And I think there's some kind of good practices to shoot there, but generally you can get pretty close with a CDN, but that last little bit is the hardest part.
Okay, so here we're talking about CDN, but now it's also this question of origin offload. How are you not going all the way back to origin? Because there's a real cost to that. I know with how CDNs work today, often like CDNs might be caching things in multiple places around the globe or whatever those users are. And that could be maybe 10 different separate stores that each have to hit the origin separately. So are you saying that so that the cost of having to kind of refresh that every day and keep that going is really costing companies money?
Yeah. I mean, again, so the biggest cost for folks in the cloud is egress costs. If you go look at your bill, you got all your compute, all your storage, all your different applications to use, and then there's this egress cost, right? And so that's where clouds not penalize you, I guess tax you would be a better thing for taking data out of their cloud. And so all of that egress cost is generally, some major percentage of your overall bill. So lowering that egress cost is a major motivator to kind of keep your cloud costs under control. Caching the data outside of the cloud is a way to do that. And again, that could be any kind of content. We keep saying content here. The other thing I guess I should say is what we keep saying offload. And offload, again, is kind of the ratio between the number of requests that come from users and how many are served from the cache versus how many you have to go back to the origin to get. And so it's usually a percentage. We're looking at 50%, 80%, 90% offload. So 90% would be for every 10 requests that come in, 9 of them are served from the cache and only 1 has to go back to origin. So that's kind of the you'll hear it talked about in percentages there. So yeah, I think that the cost is a big driver and the performance is a big driver. And you mentioned kind of like multiple stores that maybe are in multiple languages. So now there's multiple versions of the same piece of content, or we've got different kind of cache keys that we've got to look at by region or by different currency. As soon as you start to fragment based on all of those different aspects, now we've just made that long tail even longer because we might have 4 or 5 or 6 different versions of the same piece of content to serve those different stores.
So you touched on it a little bit. You were bringing up these like point of metrics here. Like, what are those metrics to really see how successful we are with a caching program? What do you say? Like, what should people shoot for from an origin offload perspective?
It depends on what the kind of content is. And so I kind of have, in my mind, these are my kind of goals to shoot for. But if we're looking at like API content, right? And a lot of people just think you can't cache API calls at all. And that's not true. Even if you could cache something for a very, very short period of time, it's super powerful. Even 0 seconds. And we could get into the kind of very technical pieces of time to live, but I won't go there. But like 0 seconds is a real thing to cache for. You kind of have to wrap your head around that. But for API content or very dynamic content that changes very often, I'd say a great kind of CDN offload to be looking for would be 50% or more. We should be getting kind of in that range. For short, short TTL content, like maybe base pages, HTML, like we were talking about with pre-render and that sort of stuff, you're going to want to be like 60 to 70% or above. And then for all of your images, video, JavaScript, CSS, all those kind of static content things, we want to be well in excess of 90%. And again, for a small content catalog, that might be very easy to achieve on a CDN. But for some of the retailers that we're working with, they have 70 million items, and those items might have 5 or 6 images each. You can see the catalog is starting to explode here. And so right now, some of them are only seeing 50 or 60% offload on those base pages or on those images or videos or whatever. And that's where they're struggling because that last 30, 40% is really hard to get in that request-driven CDN model. So in general, like if you're 90% or above, like really good, but that last 10% can still be painful, right? Those long tail pieces, even though they're not accessed often, might be super valuable. They might be SEO landing pages. They might be certain pricing calls or certain search results. Whatever they are, even though they're not accessed very frequently, they still could be very, very important for whatever your transaction.
That makes sense. So for some, if those, especially those at scale, this has like a real dollar amount to it. Like I'm guessing like in the millions of dollars for some of these retailers.
It could be, right? Like I think you could go look at what the average odds are on. I don't know, is 20 or 30% is your normal base kind of egress cost of your total cloud cost. Was the last time I looked at it. And maybe it's higher than that now. But like, yeah, if you're spending $1 million and 30% of $1 million a month with a cloud provider and 30% of that is egress, like every extra percent of offload is real dollars. And you could do the math, right? Like how much does it cost to serve a byte from my cloud provider? That you could actually do the math and see that. And so for every byte that we can save, you can, draw a straight line to cloud saving.
So there's that cloud savings, but there's also, it sounds like there's this revenue piece to it. If you're delivering that content faster, you can have higher conversion rates and so forth.
Yeah, I mean, we talked about performance this whole series, and that's what it comes down to, right? So when we're serving that, whatever that piece of content is, closer to the end user, it's going to be faster. And when you do it from a stack like Harper that's retrieving it from an in-memory cache, or all of these different pieces of a stack on the same device, again, we're not transiting the network different places. And so we can serve it in a faster way.
Really trying to achieve those higher levels of cache. I think there's this difference between like a passive cache, which is often what CDNs are doing, and then an active cache. Talk to me a little bit about the difference between those two, and how do we, like, which one really achieves that higher level of caching?
Yeah, and you could go look up, there's 5 or 6 different strategies, like pull through and side by side, and very different caching strategies. But again, the bottom line with the CDN is generally it's request driven. So something's got to happen in order for an object to get in that cache, which is great for frequently accessed items, but not great for infrequently accessed. So that active cache where we're going and pulling something in asynchronously according to some schedule, or again, you could push that in based on when content changes, you could push that content out to a dedicated cache. Whatever that interaction is there, it's not waiting for the request. And that's what's super, super important, to get that object in there before it's infrequently accessed on that long tail. So that's the most important part, is get that object in there, whatever strategy, push or pull, that's not request driven. And then the second thing is retain it for as long as you can. Again, since it's a dedicated cache, you can set those rules. You can have it stay there even longer than its TTL. And then again, you could use a strategy like stale while revalidate or other things to get more time out of that, to make that object more durable in that cache. And because we're automatically replicating that everywhere, that object is living everywhere that it may need to be on the Harper platform.
Okay. So within the Harperverse, we're kind of doing some of the things that CDNs are already doing, but we're also doing, it sounds like, more of that as well.
Right. Yeah, I think it's a little bit different. And again, because you have the complete control over that, how much space do I need? Where do I need those cache notes to live? How long do I want to retain an object? How am I going to get that object in? How do I want that object to be refreshed? It really gives you that maximum control. So we usually will still sit behind a CDN. You still want that first layer of cache to be that CDN, but this adding in this second tier really gives you that maximum flexibility to achieve those higher level of offload, rather than just falling back to whatever the cache may be in your origin, right? You still may have additional layers of cache behind Harper, but remember, they're in that expensive cloud origin that it still costs money to get things out of, and we're one step beyond.
I see. So kind of more of that edge deployment for the scenario, being closer to those users.
Right. Yeah. And then again, performance, cost, all those things come down to it. But the high level of kind of configurability and flexibility is what gives you the real value here of using Harper.
Okay. So in the scenario when somebody's using Harper, how long does it take to stand up a long tail cache solution for them? What's that process look like from a deployment kind of service standpoint?
Yeah, it's really pretty simple. Again, it all comes down to kind of what the workflow is about how you want to get that content in there. So deploying on the platform can be minutes to hours, depending on how many nodes and where you want them and what the replication strategy is. And then it's kind of there ready to receive the cache. So the deployment is not necessarily the hard part. It's figuring out how am I going to get that content in and figuring out that strategy, because it's going to integrate into whatever your content management workflow may be. So again, if you want us to pull, great. how do we know what to pull? Are you going to give us a list? Do we need to crawl? Do we need to observe some sort of real user monitoring metrics and kind of calculate what we should get? Are we going to be that pass-through cache that's request driven? Are we going to have that content pushed in, and you're going to do that based on your publishing cycle? So it really comes into how do we work that cache into your workflow, and making changes to that workflow. Generally, those are pretty simple, but it's just something that we need to think about. It's more kind of an operational piece to fit in than the technical problem of, hey, how do we deploy things or get stuff on there or make API calls? Again, because we have the built-in APIs, because we've got things like GraphQL and all the TTL controls and other things built in, you don't have to create a lot of application layer stuff to get your content into us. It's more just how and when is that going to be event driven to get the content.
That makes sense. So it seems like there's a lot of options out there, a lot of avenues to pursue. But either way, it's like kind of a quick way to really accelerate a user experience for every single page on a website.
100%. And remember, not just pages as well. That because again, we've got real flexibility in our cache. That could be images, that could be videos, that could be JavaScript, CSS. And again, don't forget about the API calls. So we do have a number of customers that are using us purely for a GraphQL cache, or for actually generating GraphQL responses. So we can do a variety of different things, and that long tail might be any sort of content, not just pages, or not just. A lot of people always think of content as like images. I really think people undervalue looking at how can I cache my API content. And get that offload there, because it's very, very chatty. Even though it's not big from a size perspective, there's a lot of calls in a modern web application, particularly on a mobile application that's all API driven. There's a lot of API calls that have to be made in order to assemble whatever the interaction is that you want the user to do. And those are just as potentially cacheable as anything else.
Wow, yeah. So almost like infinite possibilities here on what we can cache.
Yeah. It's kind of like, can we cache that? The answer is probably yes. There's costs and trade-offs, right? And at some point in time, caching everything doesn't necessarily make sense. But most times that we interact with a customer, they're not caching as much as they could or should, and just some couple tweaks and changes to their operation, and they can get really big increases at all.
Yeah, so it sounds like almost like starting with an assessment of what are we caching today, what could we cache, and then getting that deployed and to accelerate those experiences.
Yeah, and tie it back to that value, right? What is the value of caching that? Am I going after performance gains? Am I going after cost savings? Am I going after critical business interactions? Am I trying to move pieces and parts of an application to become multi-region? And we've got to have a cache out there that the application is actually accessing rather than the user. So variety of different reasons why you would, but I think starting with why, and then understanding where we're at, understanding what targets we're trying to hit, and then going and deploying the strategy to get there is the kind of the general process. Yeah.
Awesome. A lot of great points, Jeff. Thank you again for doing this. We'll have to do another one on a probably API cache exclusively here.
Right, yeah, there you go.
Thank you for joining today.
Yeah, thanks, Aleks.